Good afternoon. Welcome to the latest edition of the National Security Space Association's SpaceTime interview series. My name is Scott Pace. I'm one of the senior advisors to the NSSA. Your normal host, Chris Williams, couldn't be with you here today, but I'm thrilled to be able to fill in and to welcome our speaker today. Thank you, all of you, for joining us. NSSA is the only trade association devoted solely to the national security space enterprise, both Title 10 and Title 50, and we seek to promote a constructive dialogue and partnership between government and industry. We're pleased to have with us today Dr. Steve Meier, who serves as the director of the U.S. Naval Research Laboratory's Naval Center for Space Technology, or the NCST. NCST's core mission is to develop innovative basic and applied research through advanced development of spacecraft technology and ground command and control stations. Dr. Meier provides executive leadership and direction to the NCST, and is responsible for all personnel, finances, programs, facilities. He serves as a national authority on matters related to space technology to top Navy, Department of Defense, aerospace industry, and allied foreign government leaders. Dr. Meier has held executive level positions at NASA, the National Reconnaissance Office, and Lockheed Martin Corporation. He has also led the creation of organization-wide technology roadmaps to guide investment strategies for seamless transition of technologies from research and development to actual operations. He served on several independent evaluation teams and study panels that have strengthened federal acquisition regulations, enhanced technology management practices, and developed organizational cost-effectiveness guidelines. He's a member of the Senior Executive Service and a senior aerospace executive with more than 25 years of experience in the federal and private industry fields in defense, intelligence, and civil space communities. Dr. Meier was first appointed to the Federal Senior Executive Service in January 2011 at NASA, departed to private industry, returned to the SES cadre in July of 2020. He's led highly diversified program portfolios focused on delivering innovative technologies from concepts to operation for both air and space platforms. I also want to say on a personal note that he's one of our adjunct instructors at George Washington University, where he teaches a course in the acquisition of national security space systems, which we commend to all of our students. So I appreciate his teaching duties with us as well. Dr. Meier, really thanks so much for being with us today. I want to make a quick note about our format. Dr. Meier will provide some opening remarks together with slides, and the slides will be posted on the NSSA website soon after the completion of the interview today. As a reminder, that website is www.nssaspace, all one word, .org. If you have questions for Dr. Meier, please use the Q&A button at the bottom of the screen, and I'm going to try to get through as many of your questions as possible, given our allotted time of 60 minutes. With that, Dr. Meier, the floor is yours, sir.
Oh, well, thank you, Dr. Pace. I appreciate that introduction. And thanks, everyone, for joining us today. So hopefully find this enlightening brief on what the Navy's involved in space, because a lot of people don't map out Navy and space together. And I'm going to kind of run through and provide some information on that. So the first thing I'm going to do is run through what the Navy's interested in space, and also what the Naval Center for Space Technology is involved in. And I'll be probably using the acronym NCST you'll hear throughout. So in the first slide, if we could switch to the first slide, please. It's on the Naval Research Lab. So one thing I want to start with is we are almost 100 years old as of next year. So we came out of a brainchild actually of Thomas Edison and Josephus Daniels, Secretary of the Navy. So they said that the Navy needs a R&D lab to be built, and Thomas Edison was a core member of trying to get that moved forward. So he and the Secretary of the Navy built the lab and then moved forward in terms of that. So we came around, and the first two subject areas were actually radio and sound on the river. So those were the first two, and we're celebrating 100 years. Next slide, please. So NRL is not just about space. Here it talks about NRL first. There are many different activities that go on. So anything from the first radar was invented here, and that came about as ships were transversing up and down the Potomac River. They noticed some reflections coming off of that, and NRL started the first radar program that was used in World War II. Other things like the improved aircraft canopy, there was an acrylic plastic that was found to be lighter and more durable and stronger than normal canopy. The first U.S. intelligence satellite called GRAB was developed here as well, and also the first U.S. Satellite called Vanguard also. And Timation is the precursor to GPS that was delivered here as well. All of you probably have at least 6 or 7 different devices that depend on GPS. So that started in the 60s and 70s. And then Clementine was a spacecraft that mapped out the moon. And then we also do free space optics. We have a really core program doing optical communications for the Marines that turned over to be their first major defense acquisition program. And then most recently, we just were designated a DoD Quantum Research Center. So as you can see, it's a very broad organization. And then on the next slide, please. Here is the organization. There are 17 research divisions in total, and I'm over there on the far right. So one of the big advantages of working with NRL is you get access to all of these different research divisions. You know, anything from biomolecular science to space to chemistry. So I would say we do everything from split the atom to go out to geostationary orbit at 36,000 kilometers. So about, you know, a large chunk, about a third of my money actually goes out to some of the other organizations, and also theirs come in. So it's a very broad organization. So next, I'm going to go into NCST, please. Oh, I'm sorry, one more slide on NRL. The one thing we are is very broad and deep. As you can tell, we have about 1,800 science and engineering professionals, and about half those are all PhDs. We cover a wide range of different disciplines, as you can tell. So a lot of times when I'm looking for someone who's an expert, I can actually go down the hallway and find them, and sometimes look up in a journal or thereabouts, or you find them working in another area of the lab. So it's really amazing that we have such breadth and depth at NRL. Next slide, please. So now I'm going to jump into the Naval Center for Space Technology, NCST. So before I get into that, the first thing I want to talk about is, what does the Navy care about in space? This is one of the key slides. I think, you know, most people do not map out and connect Navy and space. First is weather and environmental monitoring. You know, clearly you want to know what the weather is, what you're getting into, and where you're going. So that's one of the key areas that we use space products from. ISR, intelligence, surveillance, and reconnaissance, is also used because we want to be able to identify friend or foe, and anything from a canoe up to a freighter. And then position, navigation, and timing, also called PNT. We do work in atomic clocks, because sailors and Marines need to know where they're going, where they're headed. So that's a very key area for the Navy as well. And then satellite communications, you can really never get enough communications. So SATCOM, as they call it, is communications all over the world and at high latitudes and underserved areas. So we're definitely interested in that as well. And then lastly is the missile warning and overhead persistent. This, of course, is looking at missiles being, you know, shot from land or from ship to ship. So those 5 areas kind of cover what the Navy is interested in space and where they get a lot of their products from. Next slide, please. So I believe every organization should have a mission and a vision before you get moving forward. I've only been here about 2 years and a couple months. So the way I view us is, our mission is about speed. Most of our programs are on the order of 2 to 3 years. Some are a little bit longer, which I'll talk about, but we're kind of fast and nimble, and we have small development teams. We're first movers in the sense that we're generally the first ones to do a new type of satellite or methodology. So, and then we burn down the risk, develop that, and then transfer it over to industry. And end to end, I'll talk about, we do everything from orbitology to ground stations, and then we have some core customers in the DoD. So that's really kind of the mission of the organization. The vision is, we aim to be transformational. We want to do things that have never been done before. new paradigms, new models. That's kind of what our main thrust is. We're not here to stamp out, a bunch of Iridium satellites. That's not our job here. And with that comes innovation and invention. And by innovation, I mean taking existing technology and then making it better in some way. And by invention is starting something from ground zero, kind of like what I showed you on some of the satellites that we covered already. Next slide, please. So I think this chart really represents the depth and breadth to some degree of all the satellites, key ones that have been launched by NRL. So starting over to the far left, you see Vanguard, the first US satellite launched after Sputnik. And then SOLRAD is also known as GRAB. That is the other satellite, the first reconnaissance satellite. And then as you kind of work your way through, you'll see Timation in there. As I mentioned already, the precursor to GPS, Clementine. TACSAT-4 is a high latitude communication satellite. And then our biggest program right now, and has been for the last several years, this is one more of the longer programs, is RSGS, Robotic Servicing of Geostationary Satellites. So this is a program we have with DARPA, who is funding us to do that. And essentially, we're building 2 robotic arms, and we're going to be flying this out to GEO to service a satellite that is not meant to be serviced. So it's very powerful in terms of the abilities it's going to be able to do. And then our other partner in that is Northrop Grumman. They are working on the satellite bus where we're building the payloads. So I'm hoping you see everything here, the variety and breadth. And our history goes back all the way to the NRO days. We were actually Program C in the NRO, if you remember that. There was the Air Force, the CIA, and the Navy, and we were the Navy. And we came out into the white world when the NRO did, I believe, in 1994. So again, wide things of satellites, everything from CubeSats up to 15,000 pounds is what we deal with here. Next slide, please. And then on the end-to-end, what I'm mentioning here is we have ground stations as well. 2 of them, Blossom Point was probably the first ground station that was ever came onto the US soil in the late 1950s. And what's really unique, it's down in southern Maryland, is the fact that it is truly 24/7 lights out autonomous. That sense is you walk into the control room and it's really the size of a large office, and at most there'll be one person on one of the 8 or 9 computers that are there, compared to if you go to an NRO or NGA or NASA, ground station. It's huge with big screens and lots of people and shifts that rotate, 3 shifts every 8 hours. That's not the case at Blossom Point. We can insert any payload, any type of satellite into there. So it truly is a unique facility that we have there. And then Pamunkey is another facility we have only about 10 minutes away from Blossom Point. And that consists of a 30-meter full motion antenna. It's really the fastest one in the U.S. Just to give you some idea of how fast it is, it can turn 360 degrees, do a complete circle in a little less than 2 minutes. So that's pretty good for a 30-meter antenna to move with. So that's the end-to-end piece. So we have people, again, doing things all the way from orbitology to design, build, assemble, integrate, test, and then ultimately operate. So that's, I feel, what makes us unique. We're truly end-to-end, and most of the people in my organization have had that experience of going through the full life cycle, called cradle to grave, as they would say. So with that, I believe that is my last slide, and I will turn it over to Dr. Pace for any questions that he might have.
A reminder of viewers to use the Q&A function if they want to put any questions in queue, and I'll get to as many of them as I can. So you've talked about the main objectives of the NCST, but how does, from your perspective, how does that fit into the overall sort of Navy's mission? Navy and sort of DoD goals. I know you have this sector that you're in, but when NRL is described and proposed to more sort of seniors, how do you position yourself, in the Navy mission? What is sort of unique about what you do, and so why the Navy does an NRL and does a space science technology program in particular?
Sure. We are part of NRL, of course. And then with that, what makes us unique is we contribute also to other DoD programs and they to us. I mean, the weather we provide is not just entirely for us. Other forces use it as well. Likewise with the SATCOM, that is used throughout globally. And then also with the other programs related to the ISR and also some of the satellites that we're tracking. So a lot of it is we're sharing this information with other DoD components, and we fit into that unique niche where we get that information, we share it with our combatant commands, and then also with other naval forces. So in the history, I guess the best thing I can say goes back to the program Sea Days is when they started building these things for the Navy. But essentially, it's it's a vital element of work to ensure that naval systems are working with other DoD systems together.
Got it. So tell me a little bit about what your reporting chain looks like. You have that organizational chart, and you see that breadth across there, and you go to your directors, and where do they fit into the Navy, and then how does that eventually, or does it connect to the combatant commands? How does it connect to other services, and how does it connect to other folks? Where do your bosses go?
Sure. My boss, as I'm one of the 4 associate directors, is the director of the Naval Research Lab, Dr. Bruce Danley. And then Dr. Danley reports to the Chief of Naval Research, Rear Admiral Lawrence Selby. And then the Chief of Naval Research reports to the Assistant Secretary of the Navy for Research, Development, and Acquisition, Mr. Tommy Ross. And then Mr. Tommy Ross reports to the SecNav, Mr. Del Toro. So that's kind of the chain of command all the way from where I sit all the way up to the SecNav level is where it is. And then we work there, we're part of several combatant, the combatant commands, the COCOMs, working closely with a lot of the other services together to, again, build this like unified mission working together.
Cool. So, so you have that technical expertise there. Can you comment, or to what extent do you have projects, or have you done projects that wind up working more directly, like engineer to engineer level, with Space Development Agency or the Space Force and other sorts of organizations?
Sure, I can talk about a couple of those. We have, for example, working with the Space Development Agency, we're doing their entire mission management for their Tranche 0, which is 28 satellites. So we're doing the mission management, the systems engineering, the trade studies, everything that needs to get done to do the entire ground segment for the Space Development Agency. So there's a lot of engineer to engineer interactions that's going on. And furthermore, with that, we're working with 4 contractors because the Space Development Agency has 4 different spacecraft that are going out on Tranche 0, that include L3 Harris, SpaceX, Lockheed Martin, and York. So we're also working with private industry through SDA. As I mentioned, the RSGS program, that's working closely with DARPA. They're funding us to do the 2 different arms. And then we're working very closely with Northrop Grumman. It's kind of a triumvirate between all 3 organizations, and they are building the satellite for that. So that's definitely some of the key programs that we have going on at NRL that work, again, with commercial, working with the government, but also with commercial entities as well.
Cool. So, as you do these kinds of cooperating, do you have areas where you feel that NCSC has like particular expertise, as opposed to like, just smart guys, or do you have areas where you're particularly strong at, and therefore other people should go, hey, I want to use those guys from NRL because what's your maybe a comparative advantage, if you will, on technical expertise?
Sure. A few of our real key areas I feel that we're experts at is, number one is in AI and machine learning. That's really key right now for any spacecraft. A lot of people, like on RSGS, you would think that the 2 robotic arms would be very, the hardware would be the hard part. Actually, it's the software, because these are doing a lot of autonomous movements in space at geostationary orbit. So there's a lot going on there that's, AI and ML related. So we have teams in both of my divisions that are heavily involved in that. Space robotics, again, we started that back about 20 years ago. That's one of the ideas of like the bottoms up innovation you get from NRL. Somebody wrote a proposal of a couple $100K, like, hey, why don't we do this thing called space robotics back in 2002? And funny, it got funded. And then guess what? It's blossomed all the way through the last 20 years to where we are right now, building 2 robotic arms for DARPA. So I'd say space robotics, we have very deep expertise in that area as well. Optical comm is another big one. As I mentioned before, we are called the Naval Center for Space Technology, but we also do work on the ground. That was for the Marines, that program, and it's optical comm. So essentially, we're taking all the knowledge transfer we have from there, doing it on the ground, which is actually much harder because you have humidity and turbulence and other areas along those lines that make it quite difficult, and transporting that information and the experts to our SDA work, because SDA is using optical crosslinks for all of their satellites, and also they're doing experimental tests with uplinks and downlinks for optical comm. So again, it's using one scenario, one application, and then transferring it over to the other. It's one thing we do quite a bit here at NRL. And then wireless power transfer, that's kind of power beaming. That's something we just started up recently. That's essentially, providing power wirelessly, like through a laser. So we've demonstrated that experimentally on the X-37B space plane. So we took a little chip up there and had sunlight come in and hit it and emit microwaves down and light up. So power transfer is another one, wireless power transfer and power beaming, that we're really interested in. And all of that translates over into space solar, where essentially the sun would be your energy source, and you would take that, put it into, this is far off into the future, a very large dish. If you were in the microwave, it might be like 1 kilometer in diameter or something along those lines. And then, go ahead and transport that down onto Earth. And that gives you globally transmissible energy, anywhere on the planet. And if you were to say use a laser or something like that, it could be in a LEO orbit and probably about a 5-meter aperture. So that's some of the power beaming work. Hypersonics too is one area that I want to bring up that I believe NRL is really a key player in. We recently just are completing a wind tunnel, which will be done when have an IOC around December or January. So we've invested our own money. And then last year we won the DoD ARAP, which is the Advanced Research, Science and Technology Priorities Program. And that gives us a 3-year, $45 million program where we're the program managers with it, but we're also working with AFRL, MDA, and ARL, along with 20 universities. So in addition to just all the research we'll be doing, our predictions are we'll probably get close to 20 to 25 PhD dissertations and master's theses out of it as well. So I see us as truly experts in the hypersonics place, and this over the next year or two will be the place to be. And then astrodynamics, we're looking at different satellite guidance, orbit determination. Both of my organizations are heavily involved in orbitology, also involved in tracking some orbital debris as well, which all of us know is a huge, huge problem burgeoning each day with all the satellites that are going up there and some of the recent collisions and the ASATs that have occurred. So astrodynamics, I'd say, is a very strong suit. And then position, navigation, timing, one of the key parts. We're involved in building atomic clocks and others to get more precise, more accurate, and also to help with navigation and timing. So, and then with that, the other area with PNT is alternate PNT. The GPS constellation is pretty fragile, as what I'd say. So we are developing other ways where you could use sources and be able to navigate your satellites without using GPS. And then lastly, probably multi-infusion. That, as many of you know, is overlapping EO images with IR, radar, along those lines. So doing real-time, big data type of analysis, looking for unique identifiers, advanced filtering, things along those lines. So those are a couple where I feel we're truly experts in, and people could come to us and we could contribute value.
So in addition to the military side, it sounds, I'm just thinking that there's a lot of overlap actually with civil entities. So, the astrodynamic stuff of interest to the space domain awareness work that Commerce is doing, some of the orbital collision work that, of course, Goddard is involved in, large cloud computing that NOAA and other parts of Commerce are going to care about, optical communication that NASA cares about. So it sounds like there could be a good sort of augmentation of other agencies' technical capabilities in partnership with you. So does that already happen? There already are, not just within the military side, but there are civil, partnerships with NOAA and NASA with NRL, or has that occurred?
Yes. We actually work across the entire community, as I'd say, including all the civil organizations. We work with all the DoD components and also a lot of the IC agencies as well. So yes, we do have, we work closely with NOAA because they are getting into being the Department of Commerce, the space economy, orbital debris, space traffic management, things along those lines. So our orbital teams work with them. With NASA, our biggest connection is with the orbital servicing and advanced manufacturing. It's something initiative called OSAM that's out there. So we work very closely with the NASA Goddard folks on that. And also we're looking at areas that could be down the road used for refueling or other areas along that, refueling in space. So those are some areas we're starting to look at in the robotics side as well. So yes, we're working very closely across the board with almost every player in the space community.
Just to sort of nerd out on a personal level, the hypersonic wind tunnel you're talking about, is that continuous flow or is it a shock tunnel? And if so, what Mach do you get?
Oh, geez, you got me on that one. I'm not sure about the flow of the shock, but I do know it goes up to about a Mach 5 or 6 is what it's going to go to. And what's unique about it is it spans a wide range of Reynolds numbers and can also test up to about 60 to 70 seconds, which is apparently very long for most wind tunnels. They're much shorter tests.
That's long.
That's the way the way it's set up. So yeah, that's some of the unique qualifiers about the hypersonics wind tunnel.
Cool. So tell me a little bit more about you talk about all this work for others. Tell me a little bit about your business model. I mean, an FFRDC gets a tranche of money and then argues about how to spend it. Private companies, bid for contracts and whatever they can get, and when they take that. Other places use working capital funds that have funding, but then they have to replenish it, through work for others. How much do you have just as a budget, as a baseline, and how much of it is coming from outside the Navy?
Okay, sure. That's a really good question, Dr. Pace. Well, the way we operate something, and we have always operated, is something called the Navy's Working Capital Fund. That's the business model we have. So essentially, outside of a very small percentage, I'm talking tenths, the majority of our money all comes from external sponsors. It's going to be like 99.8% or something along those lines. We get just a little bit for buildings, but very small. So that's the model that drives us. So that's all my salaries, operating facilities, everything, calibration facilities, they're all funded by external sponsors. There's no internal funding at all. So that drives us to operate a certain way. It's really running in a private industry business model where you have to bring money in. And what happens here is that divisions do shrink. A lot of people get rift at times, or branches will dissolve because you do have to bring money in. So we are a federal entity, DoD lab, but we end up writing white papers to other DoD organizations, white papers, proposals to other DoD civil organizations as well to bring money in. So we view it as it's a double-edged sword. On one edge, it's stressful, because you have to bring money in all the time. On the other edge, it creates a lot of bottoms-up innovation, is what I would call it. Coming from the ground up, because it's all a bunch of white space you have to develop into an idea. So people can come to NRL and really start their own business to some degree. If they write a few white papers, they bring in some funding, they can hire people, and that's the ability to grow the business and get it moving. So it is a bit unique, and all the naval warfare centers operate as well in that type of model to the working capital funded. So
it kind of, it's not exact, but it reminds me of NASA Goddard. Has a number of very, very cutting edge scientists, but they have to compete. They have to bring grants in, but by competing in peer review, that's in part how they maintain quality. So it seems odd for a government facility person having to kind of compete, but it is something that happens, and it's part of the reason I think that that they're able to do sort of quality work. And JPL has FRDC is different model, but they also have to compete, and so not unknown. So then a number of questions coming in on the Q&A side. I think trying to understand what it is. You're a research laboratory, so what is it? When does something translate into a program of record, as we would say, or what is something that you would not do as it moves toward operations? And you talked about cradle to grave and all that sort of stuff. Can you talk about how is NRL's portfolio split between ground segment, demonstrations, subsystems, payload development? It might be, I might take away that it's whatever your customers sort of want, but how do you plan and think about what it is, areas you want to go after? Do you have any work which is maybe considered operational, that people pay you to operate something, or is it really all research that you hand off at some point?
Yes, it's generally, well, some people call us also, you think of like a coin operated machine. You put in a couple quarters and you pull the handle and something comes out. So we are, we come up with ideas because we are a lab. And, what we do is usually do a one-off to some degree. It's a one-off, and we have already have the ground segment down there. We have a couple programs called Ocean and Neptune and VMOC, which we license the private industry. So those are, to me, you could say fully operational and licensed. But I'd say the thrust of what we really do is building spacecraft. That's kind of our bread and butter in terms of the majority of the portfolio. So I'd say it's, the split I'm not exactly sure of, but I'd say the majority is of anything, again, from CubeSats to RSGS sized payloads. So that would be thing. And I'd say we go to operations and then we hand it off to someone. They take it over and then they decide what to do with it next. So, and it's working hand in hand with another service. Again, like that optical comm one, we were doing it on the ground. The Marines, we got its operations. We did tests all over the world, Alaska, over in Asia and Japan, Australia. We took it all over to different places, tested Marines, everything turned out well, and now they're operationalizing it as their first, optical comm MDAP. So we do go all the way to operations, I'd say, and then it's a handoff that occurs. And the one thing we always try to avoid as best we can is what's called the valley of death. Where you end up building this program and people put a lot of money and then you have no transition partner. So I really view, the transition partners, you need to find an end user very early on in the game, who's going to be the end user, and also from the end users get things such as their system requirements document or SRD, their interface control documents, the ICD. Get those early up front so then you can map it all the way when you're starting to build it. Because I've seen so many programs get built and not be transitioned because, again, nobody was looking at what the final requirements were, what the interfaces needed to be. So that's one thing that we do very early on is interface with the user, get them on board, and to me that has proven to be a successful method for transitioning programs over.
So can you talk a little bit about then how do you coordinate or then deconflict, these R&D activities with, other organizations? Our Space Systems Command, the NRO, Air Force Research Lab. So it sounds like these folks should be both partners and competitors at different times and different places. So is there in a formal process, or is it, mostly driven by markets and customers?
So to a large degree, I wouldn't. There's all the above. I meet with senior leaders from all those organizations, so we have some discussions at a high level. But then I would say most of the discussions are at the working level, the engineer to engineer, the scientist to scientist level. Those are the people that are working together on, TEMS, technical exchange meeting, and other areas like that. So they understand who's doing what where. So, we kind of try to hit it from both the top and the bottom. But I would say the majority of trying to avoid duplication is from the bottom. Most of those, because there might be 100 engineers and scientists working on one program or across several, and they all know their partners and who's doing what where. So I would say it's that type of communication which keeps us clean and trying not to reinvent the wheel somewhere else.
That sort of sounds like academia is like that. I mean, if you go into a particular part of academia, I mean, all the people working at it, they all know who the other really good people are in the area. And if you ask, the dean of research or vice provost for research,
Right.
what the strategic plan was for coordinating with another university, they wouldn't know. But the people working in the departments, they know
Mhm.
who everybody else is. Does NRL or where does NRL fit with respect to sort of other sort of naval organizations that touch on space? The 10th Fleet, Naval, Information Warfare Centers, and all that sort of. What are the swim lanes? Who does what in these areas, and how do you sort of coordinate or stay out of each other's ways or support each other?
Yeah, it's actually a very similar answer to what I just gave. I mean, they are all under this Navy working capital funded model, so they
Okay.
go and put money out for S&T as well.
Okay.
And most of the interactions happen at the engineer and scientist level where we deconflict programs. So that's pretty much
Same
the
thing.
answer. And
Yep.
but I would say NRL is truly focused. We're the Navy's corporate research lab, put it that way. So we're really focused on 6.1, 6.2 type of research, which is basic research and slightly applied, so to speak, getting closer to 6.2 all the way up.
So that in terms of doing like 6.1 and 6.2, kind of, it doesn't sound like that would conflict much with the private sector, that you might maybe leverage something for the private sector, but do you ever find yourselves competing with the private sector, do something in-house versus going outside at those early stage levels?
No, generally not. That's a great observation that we don't. I mean, because the private sector has IRAD money, which is internal research and development, which can be 6.1, 6.2 like. So they have that having come from the private sector. And but we are essentially put a lot more around. I'd say our 6.1, 6.2 budget, maybe be like 20% of the lab's overall budget, somewhere along those lines. So I'm going to say about 20 to 22%. So we devote quite a bit to the 6.1, 6.2 programs.
Got it. So then the question, of course, with the burgeoning, commercial, sort of space industry, where are areas where either you've taken advantage of things that have happened on the commercial industry side, or where are areas that you want to take advantage, or you think is promising for taking advantage of commercial developments?
Yeah, sure. That actually spans all areas. We want to advantage and leverage as much as we can. I mean, as you know, and everyone else on this call, there's essentially three components to the space system. I mean, there's a satellite, there's a launch vehicle, and a ground segment. So right now we are, doing our best to leverage as much commercial that's out there. I know the meetings I've been at the senior levels, the new mantra is buy it first, build it second. So, and these are from the very largest, spacecraft organizations that I'm talking. So that's kind of what the deal is. So for us, we can, would love to do the same thing. I mean, number one, like with the launch vehicles, back in the 2000, it was about $10,000 per kilogram to launch something around 2000. Now with SpaceX and others driving down, we're at about, approaching $100 per kilogram, 2 orders of magnitude. So that's huge. That's really decreased it. So if we can catch a ride on a lot cheaper, with one of the Navy payloads, we'll do it. Likewise with the ground stations, there's, Amazon and others that are putting ground stations out all over the world globally. If we can leverage those, we're going to do that as much as we can as well. And then I would say with the mega constellations that are coming out, that's something I call mega, or also people call P-LEO, proliferated LEO. So there's all types of satellites that are, the commercial sector's putting up. I mean, Starlink is like over 12,000, I think, and Kuiper is over 3,000 or something. So there's a lot going up in terms of that. So for the Navy, we might be able just to, build a payload, then catch a ride on one of those as well, or build something that could be an adjunct onto one of those. So all those different areas, we're going to do our best, to take advantage of all this commercial, because it's a huge boom that's going on right now in that area.
You talked about a number of technologies, beforehand, optical and cloud computing and hypersonics and so forth. In kind of within the current FIDEP, what are the technology areas you think industry can, be most helpful with? If I was a corporate research person, watching this and thinking I got a bunch of smart guys in my lab too, where are the areas where there might be the most matchmaking or interest in reaching out, and also maybe even including academia, that you think that could either augment or help NRL or help on a hard problem?
Yes, I mean, number one, I'd say is SATCOM. I mean, you can never get as much communicate. You always need more communication, and that's essentially, communicate from any, this forum, the SATCOM just covers communication satellites. So as much as SATCOM, that would be a good investment area. I do believe also in the space robotics or the orbital, servicing and manufacturing. And down the road, if we can assemble things in space that could be a lot cheaper, perhaps, such as pharmaceuticals in a zero-G environment, or materials, I think that would be an area that would be of interest as well. And definitely the AI and ML, as much as you can throw into that, because so much of at least the satellite world is going in that direction. That turning out to be the long pole in the tent. So these are things, and then multi-int fusion, big data. There's so much information coming down, being pumped down, that we aren't even looking at all. So anything that can, again, help with the filtering, getting unique identifiers, other things along those lines would be helpful as well. So those are just a couple off the top of my head. I was actually in a meeting on this about 3 days ago, and someone, we talked about what would be like the top 3 or 4. This was another government agency of what we would go after, and those actually were the top 4. So it was interesting that you came up with that question at the moment. So,
okay. And so in terms of the communities that work in these areas, we're all under a lot. Those all sound like things that are in high demand, already. Where do you go, to recruit, your research cadre? I mean, we've all heard about the difficulties of recruiting into federal service. USA Gov Jobs, not exactly the friendliest website in the world, and things like that. So, what do you do to try to get smart folks? What can you offer them at NRL that's kind of interesting and exciting? You talked a little bit about freedom of action and entrepreneurship, but
right.
What do you say, and how do you reach out to technical people?
Well, the best way we've actually found, because a lot of technical people we want to go off are ones, essentially, if we can get them early in their career. So we actually do a lot of college fairs. So going out to colleges, truly just old-fashioned setting up a booth. People we recruit that way, and we call those direct hires. So if we can go and do that, it's kind of interesting at a lot of these. I actually do some of the college fairs. To go there, there'll be lines for a lot of private industry, big firms that we all know and talk about. And then somebody might, saunter over and go, NRL, who are you guys? What do you do? And then we start telling about what we do. And with the, you know, the neat technology and everything, they actually get quite excited. Because one of the advantages is you come in here at age, you know, 22 after a bachelor's or 24 after a master's, you start building hardware. I mean, we'll give you a, you know, maybe $1 million CubeSat where you start turning the wrenches, putting the screws on there and getting real work experience early in your career. And then also one of the other advantages, I said there's 17 research divisions and I work across all of them, is that your matrix, most people outside of the large programs are working 3 to 4 different programs. So you get experience in a lot of other areas, and at least one of those programs is usually with another division. So it's again getting that, you know, real early on, getting that experience, the excitement of, you know, turning the wrenches. So those are really important aspects. And people that are, I don't know, for lack of a better word, patriots, you know, that want to go in and do good. They'll take perhaps less pay in the government to go and join, you know, NRL because they know they're making a big impact to the United States national security. So people have that. That's one of the reasons I ended up coming back. I mean, I worked here at NRL from 1998 to about mid 2002. And then when this position came up, I had a great experience, you know, a little over 20 years ago. I ended up applying and fortunately getting in because we do exciting stuff, as hopefully I'm conveying here in this interview.
Cool. And so, I mean, this is actually an issue on the, you know, I think on the NASA side. The NASA science people, is a bit of sorry for the editorial, are pretty good at getting hands-on experience, and there's sort of a flow of projects. But human spaceflight is tough. There's just not that many of the projects. So you can get a lot of experience operating things, but experience hands-on building something is something that's sometimes hard to come by. And I think there's really relatively few places, NRL is one of them, in the government that does offer that kind of hands-on experience that is really more commonly found in industry, but rarely found in government.
Yeah.
I had a question on the Q&A. I don't know the answer to this. Can you comment on the Navy's LEO RF requirements?
LEO RF, probably not. I think.
Is that a SATCOM? Is that a SATCOM thing? Or?
Yeah. I don't have the specific RF, how many gigahertz it would be. So yeah, unfortunately, I can't answer that technical question.
I didn't know either. I thought I would go with that. Okay, and then looking at so other questions here. You know, can you maybe talk about maybe if there are examples of how the use of space technology has you know, either changing or has affected how the Navy does its missions, and to what extent do you think, and I don't know the answer, that the existence of Space Command, which Navy will be contributing to Space Command, is there are things that the Navy does because the Navy needs to do them, and there are things that the Navy does because it's part of Space Command, part of the joint force. Is there a dialogue path that comes down, or do you simply see the effects of it when you look at the demand? What are customers demanding of us? And that you would then infer that there is a change in priorities, or there's something new that the Navy wants to do, or the Navy will be contributing to Space Command in some different way. I mean, some things can be top down, others can be bottom up, engineer to engineer. I'm just looking for, how do you get signals on the use of space?
Sure. It's a great question. We get signals a couple different ways. I would say the Navy has really invested a lot more the last few years into space. I mean, number one, there's been a naval space cadre for a while, and then recently there's a maritime space officer that was set up, people that work at operational commands that are getting now well versed in space and taking that back. So they've definitely thrown a lot of emphasis into people, you know, becoming really well familiarized with space and how to grab what the Navy needs. There's also other areas where we're trying to currently right now in the Navy, you know, put together some requirements documents that we can hopefully flow up. We're in the process of doing some of that, you know, to put together, say, hey, the Navy does have unique maritime mission and needs. So, and then taking that and flowing that on to, for example, like the Space Force that's in charge of all DoD space. So it's putting together some documentation. It's also as a developing this cadre of people very well educated that are carrying on, what the Navy needs onto these other commands.
Cool. If you were to pick a conference that you would want most of your technical people to go attend, is there any single place that you go that's part of the sort of a Navy space community, or is it more along disciplinary basis, like physics people go here and chemist people go there, or run by the discipline as opposed to being about the Navy or Navy space per se?
Yeah, I would say really probably, well, some of the best experiences I've had, are the Space Symposium, held out in Colorado. So I put most of my people to go, push them in that direction. So I would say that's probably the number one. There's a lot of sub-disciplines, as you said, as well. There are ones on PNT, there are ones on astrodynamics, communications. Those are all sub ones that I do not have, but I know they're out there because I recently, my own organization, put together a list for the next year of about 25 different space conferences that people in NCST should attend, depending upon their discipline. So there are quite a few out there, but Space Symposium at least is the largest one where people can get some big picture information.
Any international partnerships?
Yes, we don't have anything per se directly that we're being funded, but we work very closely with NATO. I, for example, am on like 3 NATO working groups because space has been deemed an enabler by NATO back in 2019. It was. So yes, we interact with them. We serve on their working groups, but right now we don't have any funding from NATO. So.
Yeah. I point out that under DoD R&E, there's an international sort of engagement strategy, and it covers a lot of the technologies you mentioned, but particularly artificial intelligence and quantum computing and hypersonics and so forth. And there's always this large thrash over who does what and where does it go. But you would be probably one of the performing organization, as opposed to a sponsor. You're not a sponsoring organization, you're a performing organization.
Yeah, so that's one thing that a lot of people just don't understand. We're a performer, so to speak. And it's interesting, if I go to a conference and hand out business cards, I have a lot of people that are very interested in me and, because again, think we are a congressional line item. And then all of a sudden they find out I'm not a congressional line item, I'm actually a performer. But we're not direct competitors with private industry or anybody. They find I'm a performer and then they slowly kind of drift away. But, because yes, that is a key thing. People come to us with ideas but it's more going to be a partnership, is what we're going to be doing with someone. Again, we don't, fund things. We're not a congressional line item is just the easiest way to say it.
Yeah. Okay. I get that. Then looking down, have you had cases where people have complained about competing with industry that you've dealt with, or?
Not that I have. I mean, one thing we do with industry is we do something called a lot of CRADAs, cooperative research and development agreements. So it's working very closely with industry and a partnership. And sometimes there may be a little bit of money exchanged. I've only been here 2 years and a few months. I haven't heard anything from industry complaining about us as being competitors. But through CRADAs, we definitely work very closely. We have them with a lot of the big aerospace contractors where we're sharing information and IP and other things that go along with some technology. There's also other transaction authorities that can get funding on OTAs, they're called, and also work for non-federal entities, that as well. So there's certain ways we work with industry, but at least during my time, I haven't heard industry, complaining that we're taking something from them.
I'm certain something will come up.
Yeah, probably.
Certain it'll happen someplace. And any organization will have to deal with that. Do you have, in terms of must attend or places that you track, maybe this goes back to the recruiting areas, thinking about maybe what might be my competitors in academia. Are there sort of schools that you draw a lot of people from, or a lot of partnerships with that come up more? I know you don't exclude anybody, but are there ones that are the most common partnerships? Georgia Tech and MIT, University of Colorado and Michigan, or is it all kind of
Sure.
spreading?
Yes, I mean, local is where we draw a lot of talent. That's one area that's nice because you can just drive up the street. Like, for example, University of Maryland or George Washington, George Mason University, because they're local. So it's easy to reach out to those students directly. But beyond that, we draw from everyone else. And I'm actually pushing forward a lot of diversity, equity, and inclusion type of initiatives, and going out to underrepresented colleges and trying to grab people to make the organization more diverse. So yes, I mean, a lot of them are some of those locally because it's easier to pull from people there and do the college fairs. But we also, now in this virtual world, we do a lot of virtual college fairs. And then another area where, again, it's a lot, people go back to their schools that they graduated from, and connect with alumni and pull through that as well. So that's probably some of the ways.
There's sort of a reinforcing cycle there of the importance of reaching out to HBCUs or Hispanic serving institutions and so forth, so that you can then get people that can go back and pull, from those institutions and make your diversification a little bit more self-sustaining.
Yes, definitely. I mean, just a few months ago, I gave the college fair at Howard University and also at Gallaudet, that are local universities. So.
Okay, I see us kind of coming up on top of the hour. I think we covered a lot of material, but anything you want to add, or anything you want to sort of leave with as a message? Navy, space, science, and technology. What should we take away?
Well, I guess the things I would think of in terms of NCST, one thing we do is, we create, we build, we're very fast, and we deliver. We've been doing it for over 60 years, as you've seen, and we'll continue to do it across a wide spectrum of space technologies and systems. So those are, I guess, some of the words I would want to leave everyone with: to create, build, fast, and deliver. So.
And a historical note, do you still have the interim control module that was to be used for space station if the Russians were late?
Yes, we do. I actually saw it in the lab about 2 weeks ago. Walked right past it. So you'll see that. Yes, we still have that. We also have out at the NRO. If you walk into the NRO's main entrance, there'll be the Grab satellite and Vanguard and some, I think maybe one other NRL one. There are models that are right there at the NRO as well. So yeah, we got some legacy systems floating around, or models of.
So you can go, you were there first.
Yes.
Very good.
Exactly.
Well, Steve, thank you very much for joining us. And it's been a pleasure talking to you. And I hope it's insightful for everyone that this close to our nation's capital, we have people who actually build things. A sorely needed skill. So thank you very much for your service and your dedication to the country and to the Navy.
Great. Thank you, Dr. Pace. Appreciate it. And thanks everyone for joining this afternoon and spending the time. All right. Have a great afternoon.
Okay. And we're out.